recording. Hopefully I have the right mic and speaker selected. Yes, I do. Cool, so let's get started. Hello everyone, my name is Amrit and welcome back to this Learning Python from Scratch course. This is, I believe, the 12th webinar, around 12-ish. If you haven't seen any of the previous webinars, they are up on YouTube on our SB Components YouTube channel. Feel free to go watch them and re-watch them if need be, but they are up for you to see. If you are watching on YouTube right now, do note that these webinars are done live on Monday to Friday at 1 o'clock. So if you do come in live, you can ask questions in the chat. I should start sharing my screen. There we go. Okay. There we go. So let's minimize that. So if you do come in live, I do have chat open. So if you do come in live, you can ask questions and I will be able to see them and hopefully answer them. That being said, last week on Friday, we started to go over sorting algorithms. I did kind of explain why we're kind of doing this. First reason being just to kind of practice our programming on real-world problems and concepts. And secondly, it's really useful to know these sorting algorithms because if you are going to make a bigger program, you may need to implement one or more of these. So on Friday, we looked at kind of a deep understanding into why this is a real-world problem, why we need sorting algorithms, and by the way, what we're going to be sorting are arrays. To keep it simple for us, just arrays of numbers. You can sort arrays of words, letters, all that type of stuff. Objects, if need be. But for now, we're gonna concentrate just sorting numbers, and you can tweak whatever we learn in order to match whatever you need to do. So on Friday, we did look at why the basis being linear search and why it's terrible. And then we went into bubble sort. Bubble sort is a sorting algorithm that is fairly simple. It's the first sorting algorithm a lot of people learn, and because of it, it's the first thing we learned. Now I have just realized I don't have one resource up, so when I'm talking, hopefully I could bring it up. So today's webinar, we will be looking at two more sorting algorithms and how to code them in Python, and how we will, and I'll be going through how I would code them in Python and how we would use them. I am trying to currently bring up a whiteboard very quickly. The whiteboard, just so I could explain concepts with these sorting algorithms on paper, and then we'll go ahead and code them later on. Now, in the beginning of on Friday's session, I did give you this challenge. Here we go. So this is a fairly straightforward challenge. This is a fairly straightforward challenge where from now on I will be giving you bigger programs to as a challenge, which use pretty much everything we have covered so far. So this is no exception. I will be giving you another one in a second. Now, how I have thought that we would do this is I'll give you the code very quickly. I'll skim over it just so you understand, and if there's anything special I've done, I'll give you my reasoning behind it. But I think this would probably be the best way to do this. So hopefully you've had a read of what the code should do, and I'll give you my example of how I went about to do it. So it's fairly straightforward. I have used pretty much everything we have learned so far. So I have created a record and used getter and setter methods. Of course, if you don't understand anything I say, go back and rewatch any of the webinars you've missed. Probably because you don't understand is you haven't seen those webinars, and it'll make more sense if you watch pretty much everything we've been through so far. So I have used a record. called it route. This route stores 5 things. So the route, the actual route number, the start location, end location, and driver. Note that I don't give it driver, and I have driver default to none. Reason being is because when you're creating a route, you don't really set a driver right off the bat. So hence, right off the bat set it to none. You can do that. That's perfectly fine for a record. Giving it some default values that you change afterwards. Now, no, I have get methods for all of these values, but I only have a set method for driver because in the code, you could read it again. In the code, it did say that the only thing we can change is the driver at any given time of a route. We can't change any other details, and because we want this to be an abstract data type, we can't directly access this record. We need getter and setter methods in order to do it. Hence, we have these get methods to get information from our abstract data type, and set methods, one set method to set driver to set information. So that's fairly straightforward. Now, our program did the 2 main things it should be able to do is print all the bus routes and start a new day. We kind of start a new day right off the bat after we get all the information. So essentially, we get information, so get how many routes and the info on the routes, and start a new day. It happens right off the bat. Then we give the user the option to print all bus routes, start a new day, or quit the program. So I have done it in methods. Now the first method that we should take a look at is, of course, the setup method, which is essentially this block of code here. Well, what happens here? So of course, over here, I just assume the user will enter a number. Of course, if user enters ASDF, it will break it. One way to get around that is have this in a try and catch, and just loop until the user enters something you're happy with. A neat thing I've done here is I've gone backwards. So from what the user is, that shouldn't be 2, that should be I. Yeah, so what the user enters, it goes backwards. Let's save this file, save. Cool. So it goes backwards from I to 0, minusing 1 each time. If you don't remember what range does, go back to our for loop webinar and it will be there. So it will go backwards, which allows us to do this. So 2, 1, or 3, 2, 1, or 5, 4, 3, 2, 1. So this just allows us to do that, just going backwards. And of course, we'll get into it in a second, but I do use .append to add a route to the array routes, which we create further down. New day is another thing that needs to happen. So you give it all the routes, and it goes through all the routes. So using for loops in a different way, it goes through all the routes and just asks for a new driver and sets it using the setter method. I have dotted these print lines around just so it looks a bit neat. Print routes is another thing that you should be able to do. Again, uses a for loop, goes through all the routes that we have saved, and uses the get methods to get all the information and print them out the way we need to be able to do it here. And of course, this is where the code actually starts. So routes is an empty array. We set up the array, we make a new day, and then this is the main bulk of the program. The user could enter an input. If it's something the program recognizes, it does whatever its corresponding thing is. Otherwise, we just print invalid option. It wasn't in here, but I just added it. It doesn't take that long. And of course, if user enters option 1, we want to print all the routes. Option 2, new day. Option 3, we break, because of course it's a while loop. So while true, we don't know how many times we're going to need to do this. So while true, keep doing this until we break. And when we break, just print goodbye. So let's give this a quick run. How many routes are there? Let's say there's 2 routes. That is a problem. Oh, of course, that's not I. It's going to be number routes. You could tell I was half asleep when I did this. Cool. That should be fine now. How many routes are there? There's 2 routes. There's 2 left. Bus route, doesn't matter what we enter. So let's say this is bus route 50. Start location is, let's say, London. And location just because, let's say, Paris. There's 1 route left. Let's say this route is 101. Start location is LA, let's just say, end location, let's just say, is Seoul. No, that's not how you spell Seoul. S-E-O-U-L, Seoul, I think. There we go. So we've set the routes. Now let the drivers for the first day. So let's say I am on Route 50. Let's say Bob is on Route 101. What do you want to do? Well, let's print out all the routes. There we go. Emirates is on Route 50 from London to Paris. Bob is on Route 101 from LA to Seoul. Let's start a new day. Instead, let's put Bob on Route 50 and Emirates on Route 101. And then let's print that information out. There we go. Looks good. And of course, if you want to quit, just hit 3 and we quit. So fairly straightforward. I'm not going to get into too much detail into this. If you don't understand anything, go to its corresponding webinar. So if it's if statements, if it's for loops, just go to the corresponding webinar and it should make sense. Or come into one of the live webinars and ask a question there. So let's get rid of this for now and let's get into today's webinar. Oh wait, I'll give you the challenge for today, which is this program. I did kind of cut out something just because it wasn't necessary, but other than that, everything's fine. So this is today's challenge. Take a few seconds to either screenshot it or pause the video to take a screenshot, or just take a screenshot if you're here. Give you another 5 seconds to do that. Cool. So let's get rid of this for now. I will get back to it in hopefully tomorrow's webinar. So now we are going to be looking at 2 more sorting algorithms, and the ones we will be looking at are insertion sort and selection sort. So let's pull up a whiteboard so we could discuss this a little bit better. Hopefully this works. Yep. Cool. So the first type of sorting algorithm we're going to be talking about is selection sort. So there we go, selection sort. Selection sort is probably more intuitive when it comes to an actual human doing it, but it's a little bit more complicated for programming it. But let's talk about what selection sort is. Selection sort is a very simple sorting algorithm. Well, yeah, let me just show you an example and hopefully it would make sense. So assume this is our array or blocks. There we go. So the way selection sort works is, of course, we need a messed up array with an array which isn't sorted. So let's just give it random numbers. So let's just say 5, 1, 4, 12, 3, 2, 11. So let's say this is our array. What selection sort says is you start off over here and you find the smallest number. So you go through, is this the smallest, is this bigger than this? Yes, it is. So this is the smallest number. So you look at this, is this bit smaller than this? Nope, this is still small. Is this smaller than this? Is this smaller than this? So on and so forth. So you find the smallest number every single time and you put it in the corresponding position. So since this is the smallest number, we swap these two. So our new array will look something like 1 and then 5, 4, 12, 3, 2, 11. So a new array will look something like this. But now we're on this position and we do the exact same thing. So we find the smallest number, in this case, which is 2, and we swap them. So we swap this position, the position we're on, and the smallest number. So our new array will look something like 1, 2, 4, 12, 3, 5, and 11. So we keep doing this. So now we're on this position. We find the smallest number, which is this. Then we swap these two. Then we would swap these two, just because 4 would be over here. Then and then we continue on like this until the array is sorted. So to summarize, selection sort is very straightforward. You just go through the array looking for the smallest number and you put it in the current position we're on. So we're trying to figure out the correct number that should be in here. So if we had an array like this, and dot dot dot. This array is, let's just assume this array is much bigger. Selection sort basically says we need to find the correct number that needs to go here, then the correct number that needs to go here, then the correct number that needs to go here, so on and so forth, by swapping out whatever needs to go out. So once we find what should be going here, we swap it with whatever, wherever it is. Same thing for over here. We find the correct number that should be over here and then swap it. Correct number over here, then swap it, so on and so forth. So of course, in this case, if you want to go from descending to ascending, sorry, if you just want to go from smallest number to biggest number, you're always looking for the smallest number. Of course, if you want to go descending, in this you would be looking for the biggest number. So the basic premise is the same, that each time you're going through, you want to make sure that one of the locations has been fixed. Of course, for this array, for this method, worst case scenario is n. You're going to go through the array n times in order to make sure it's sorted, n being the length of the array. So this is selection sort. Fairly straightforward, fairly basic premise, but we'll get into how we program this in a second. Let's look at the second method of sorting, which is insertion sort. So let's bring the pen back up. Insertion sort. That's an R sort. There we go. So insertion sort. Now insertion sort is fairly it's similar in a way, but it's slightly more complicated. The benefit. Oh wait, sorry. I just remembered. Let's go back up here. This wouldn't be n. This would be. So you're going through 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. N times n factorial, I think. Not too sure on this. I'll get back to you in a sec. But yeah, so the thing with selection sort is you'll go through the array, then you'll go through one less than the array, then you go through one less, and one less, then one less, and one less. So I do think it's n factorial, the amount of times you're going to be doing calculations or going through the array. So of course it's not good, but at times it's probably better than bubble sort. Now insertion sort, on the other hand, you only go through the array n once, which is a plus, but it's slightly more complicated because of it. So what insertion sort says is, let's say you have an array. Let's say this is 12, 4, 11, 1, 5, and 8. Let's say that's your array. What insertion sort says is you go through the array once, but each time you put the number where it's supposed to be. So 12, since you're on the first number, you just keep it at there, 12. Then you go to the next number, 4. Well, 4 becomes before 12. Cool, fair enough. Then you go to the next number, 11. 11 is after 4, before 12, so 11 goes here. 1, well, 1 is less than 4, so 1 goes here. 5 is bigger than 4, less than 11, so 5 goes here. And 8 is bigger than 5, less than 11, so 8 goes here. So I've kind of messed it up while writing it here, but essentially you do end up with a sorted array. The entire premise is you just keep placing the number in its correct position. So to an actual array looks something like this. So 12, 4, 11, 1, 5, and 8. So to an actual array, it will look something like this. So this you keep where it is. Then 4, so after you look at 4, your array will look like 4, 12, 11, 1, 5, 8. And then you're looking at 11, then the array would look like 4, 11, 12, 1, 5, 8. And then you're looking at 1, so the array would look like 1, 4, 11, 12, 5, 8. And of course, you sort out, so 5, your new array would be with a 5 over here. Then your new array would be with an 8 over there after you look at the 8. So hopefully that kind of makes sense. Insertion sort is a little bit more complicated, but the benefit is you only go through the array once. The extra calculations you're just doing is finding where to put that number. The downside to insertion sort, and something which people find difficult to do, is making it so, of course, let's say 1 in this scenario had to go from being over here to being over here. So of course you have to move everything here down by 1 position. So some people find that a little bit difficult, but we'll be kind of putting our programming knowledge to the test by programming these two sorting algorithms, and then we'll be testing them out just to make sure they work. So for this, I will be using methods and multiple methods for the same sorting algorithm, just so we break it down and it makes more sense. So let's go back to Python and let's get cracking. So the first algorithm we're going to go for is the selection sort. So let's call it selection sort. And in order for it to work, we need an array, which we're just going to call A. Fairly straightforward. Now, let's go back to the whiteboard quickly. As you remember, for selection sort, you basically go down. You have to go down the array, find the smallest one, and put it in its current position, the best position where it fits. So let's do that. First of all, we're going to be using a for loop because, of course, we know how many times we're going to go through. We're going to go through the entire array once, just adding the smallest number to the position we're on each time. So we're just going to say for I in range len A. So go through the array, and what we're going to do is we're going to find the position of the smallest number in the array. So we're just going to call this min. No, min is taken, so let's just call this imin. Yeah, imin seems fine. So imin is just going to be the position of the smallest number in the array. And what this is going to be equal to is a method we're going to create called find min. We don't care how this method finds the minimum. If I can spell it right, F-I-N-D. Yeah, so this method is just going to find the smallest number and give it to us in an array, starting from position I in the array. So what this basically means is, of course, we need to give it the array we're trying to find the smallest number in, and from what position onwards, which is why we have I and A, because, of course, I is going to be what position we're on, and we're just trying to find the smallest number to put in that position. Of course, we're starting from the front and going down. This doesn't need a colon. And then what we're going to do is just swap. We're going to swap I and I min in A. So that should be fairly straightforward to understand so far. Now let's actually write what these methods do. And over here, we're just going to return A once it's sorted. So first thing we need to do is write the code for find min. So find min. And in this, we just need the array and the position we're starting from. So we're just going to keep this as I, and of course, the array we're trying to find the smallest thing in. So for now, we're just going to assume that smallest is I. The position we're on is the smallest number in the array. For now, we're just going to assume that, unless we get proven wrong otherwise. So we're going to make another for loop, but instead of I using j, and we're just going to say for j in range I plus 1 to the length of a, we're going to do the following piece of code. So of course we're not going to use I again because we've already have I. We're going to use something else, a j, and we don't want to consider I, so we want to go from I to the length of a. Well, we want to go to, not from I to the length of A, we want to go I plus 1 to the length of A. Reason being is we've already considered I. We're just trying to see if there's a smaller number than I in this array. Of course, if I plus 1 ends up being the length of the array, this for loop just wouldn't run. But we are going to go from the next position of I onwards, and all we're going to do is find the smallest number. So if the jth position in the array is smaller than the smallest, I forgot to even write the if statement. So if this is the case, what we're going to do is just say that the smallest is equal to j. Fairly straightforward, and we're just going to return smallest. Hopefully this kind of makes sense so far. Essentially what we've done is just find the smallest value in the array after the position we're on, and now we're going to write the code that actually swaps it. So def swap. And in order to swap something, we need to know the two positions we're going to swap, so I and j, and the array we're going to be swapping them in. Just note, to swap two things in an array, you do need a temporary variable, so we're just going to say temp is equal to a I. It doesn't matter which one you pick. You can pick either one, a I or a j, and then you proceed to swap them. So a I is then equal to a j, and a j is then equal to a I. Not AI, temp. So essentially, you store the value of 1 in temp, replace the other one with the one you stored in temp, and then in the one you have left, just store whatever was in temp. So it kind of works like a triangle if you think about it. But that's just how we're going to solve something, and that's selection sort done. So the actual main bulk of the code will just go through the array from the beginning to the end, I being the position we're on, and each time we're finding the smallest thing in the array and bringing that to position I. So as we go along, whatever position we're on, so whatever I is, that's going to be guaranteed to be the right number in that spot. We'll test in a sec. Let's kind of go through how we would program insertion sort, which is going to be a little bit more difficult to do. So let's just add in a comment that kind of separates the two. There we go. Let's go look at insertion sort. So of course we're going to call it insertion sort. So in insert on sort, and of course we're going to be sorting an array that we're just going to call A. Fairly straightforward for now. Now insertion sort is similar to selection sort, but in this case we're going to be doing it slightly differently. So it's similar in the sense that we start from the first number and go onwards, but in insertion sort, if you remember, let's bring this back up. In insertion sort, we start from a number and then we just keep putting it in its correct place. And by the way, in tomorrow's webinar, we will be looking at more complicated sorting algorithms, but a lot more efficient. And they're probably a little bit easier to understand than insertion sort and selection sort. Insertion sort is fairly straightforward. You just look at the value you're on and put it in its correct position. But just note, we don't need to really do anything for the first value because that's the first thing we're comparing. So we're just going to assume it's in the correct position, which is why for insertion sort, we are going to use a for loop. So for I in range length of A. So we are going to do it for the entirety of A, but we're going to be starting from 1 and not 0. This is just how to specify we're going to go from 1 to the length of the array. Just again, for the reason of this, we're not going to consider the first thing because we're just going to consider that it's in the correct position. And what we're going to do is just, we're going to create a new method called insert a I in A to I. So the way I'm going about this, and hopefully this also makes sense to you, is we're going to insert this value, so the value we're on right now in this I loop, in A into the correct position, and we're just passing through I just so we know where we are in the array. So we're passing through the value of I, so what I actually is in the array. We technically don't need this, but that does make it simpler. We're passing through the array and the position we're on. And after this, we're just going to return A, because at this point, A should be sorted. Now, the bulk of our work will be done in this insert method. So insert, and we're just going to give it the value V. So that's the value of the thing. We're going to give it A, and we're on position I. Now, let's kind of think about how we're going to do this. So right off the bat, we are going to be using another for loop. Now, let's consider why. So currently, what we're doing is we're going through and we're looking at each individual position. What we want to then do is put it in its correct position. Now, its correct position is going to be less than whatever this I is. So if we go back here, let's say where I is over here, the correct position for this 1 is going to be on this side of 1. So we don't need to go past this 1. We just need to go from here to, we just need to go from the beginning to 1 less than I to find its correct position. We don't need to go past this because we know all of this is unsorted. So how are we going to actually do that in a for loop? So for, of course, we can't use I, so I'm just going to use J. So for J in range, I minus 1, minus 1, minus 1. Now, note that in this we will be going backwards, just because it tends to be a little bit easier to code. You can do this going forwards, but I'm going to be doing this by going backwards. Reason being is when you're over here, if your value is less than whatever is over here, you could just move this down by 1 and keep going. So we could go here, look at this. Oh, nope, 1 is less than this, so move this across 1 and go ahead. So essentially, this value is going to be free for you in any given time. So as soon as you look at this cell is technically already free. So we want to put 1 in its correct position. Let's just assume this. Let's just say this is 12. Where's my pen? Array, which is 4, 11, 12, 1, 5, 8. So we're in this position. So we want to put 1 in its correct position. So we look. So as soon as we take 1, we could kind of already get its value. We know what value it is, so we don't really really need to look at it anymore. We look at this. Well, 1 is smaller than this, so we can move 12 1 down. We're going to look at this. Well, 1 is still smaller. We can move this 1 down. Then we're going to look at this. If 1 is bigger than this, we're just going to slap it back into this. Otherwise, we're going to move this down and slap 1 into here. So hopefully that kind of makes sense while I was going through. I'm just going to show you how I'm going to go ahead and program it. So for J in range, so from wherever we're at and keep going backwards, well, what we're going to be doing is if our value V is greater than or equal to, greater than or equal to the current position we're comparing, so that's going to be AJ in this case, AJ. What we're then going to do is move it down by 1. So AJ plus 1. Oh wait, no, my bad. Where's the close brackets? AJ plus 1 is going to equal our value V. My bad. So this is a scenario where, if we go back here, this is a scenario. So let's say this isn't 1, this is 3. This is 3 now. This is a scenario where we've moved 11 up by 1. We're comparing it with 4. sorry, not 3. This is 5. Let's assume this is 5. So this is a scenario where we moved 12 by down, we moved 11 down. Now we're comparing it to 4. Well, 5 is bigger than 4, so we need to put it in this free cell here now. Of course, if this was 1, we would have moved down the 4 and put 1 in here. So that's the only reason. That's that scenario where what we're looking at is smaller than what we're trying to insert into the correct place. By the way, the name of these sorting algorithms kind of tell you how they're used. So selection sort, you select the correct value and put it in its correct position. Insertion sort, you insert the value in the correct position into the array. So insertion sort can get a little messy, but it's fairly straightforward to think about. So this is a scenario where the element we're looking at is less than the element we want to insert, so we just insert it one position afterwards. If that isn't the case, and of course if we've done this, we just return we found the position. Otherwise, if whatever we're looking at is bigger than what we're trying to insert, we just move it down by 1, like I was explaining earlier. So j plus 1 is going to equal a j. So that's moving it down by 1, and that's moving it, and that's putting in our value v into the correct position. If we find a value which is smaller than what we're looking at. There is one thing we haven't considered, and that's if we reach the beginning. So if we go through this for loop and we haven't inserted the value, that means we need to insert it into the beginning, and we just need to manually do that. So the first thing in the array is going to be v. So kind of think of this on a sec. This is insertion sort done. So let's play around with it and make sure it actually works. So let's print out what happens if we do selection sort on the following array. So let's just type in random numbers that aren't in order. So let's say 3, where's my commas? 3, 4, 11, 7, 16, 8, 1, 4, 20. Why is it difficult just thinking of numbers? 9, 2, 4, and 16. Let's just say 16. So let's run this, see what happens. There it goes. So 3, 4, 4, 2. Okay, so something went wrong here in selection sort. 3, 4, 4, 2, 1. Yeah, that went horribly wrong. We'll look at why that is in a second. That's odd. I can't see anything right off the bat. Oh, that's why. That's why. Okay. There you go. 1, 2, 3, 4, 4, 4, 7, 8, 9, 11, 16, 16, 20. So if you are watching this on YouTube and you did realize that mistake when I did it, you're probably just yelling at the screen. Okay, so essentially what we needed to do was compare the value at j with the value at a, the value at smallest in the array A. So if j is smaller than the smallest we currently have, of course not, so this was the position I, we needed to actually get that position, the value at that position, which is why it didn't work the first time around. So of course this is just, that's the current half programming. You're going to be making mistakes, and you kind of have to figure out where you made mistakes and sort it out. So that was selection sort. Let's see if insertion sort works. So I'm just going to copy paste this here and just replace insertion sort with selection sort with insertion sort. There we go. Let's run it, and hopefully it gives us the same array. There you go. 1, 2, 3, 4, 4, 4, 7, 8, 9, 11, 16, 16, 20. So insertion sort does work. We gave both of them the same messed up array, messed up in the sense that random numbers, and it spat out the correct array in ascending order. So that's the majority of what we're going to be covering today. Fairly straightforward stuff, just again, purely to apply the information we know so far and just solve real world problems in programming. Of course, these are fairly oldish problems and they have been solved back in the past when we needed to sort arrays. So these are methods that people came up with and are fairly famous methods that we still use to this day. So this was insertion sort, selection sort. Hopefully the understanding on how they work makes sense. Tomorrow's session we will be looking at a bit of a more difficult sorting algorithm, which will use recursion. Just to simplify things, we will be using recursion for both of them, and do then these two. These two we just kind of got out of the way just so we know them, and they are the basic ones, and you are kind of expected to know roughly how they work. So I don't see any questions in chat, so thank you everyone so much for watching. Let's see if I could quickly pull up the challenge for you guys today. So this is your challenge. Do give it a go. It uses everything we have done so far. So have fun. The entire point of this is also to have fun. You're not gonna get good at something if you're not enjoying it. So thank you everyone so much for watching. I don't see any questions. Hopefully this entire time I was using the right mic. Let's just make sure. Yep. Okay, so hopefully you guys were able to hear me this entire time. Let's pull that image back up. Not that one, this one. I'm surprised we haven't closed this one. So let's close it. There you go. So this is to do newspapers and profit. And just calculating how much profit companies make. So hopefully insertion sort and selection sort did make sense today. And I will see you in tomorrow's webinar where we will be going over merge sort and merge sort and quick sort. Quick sort being the default sorting algorithm I personally go to, and merge sort, which is similar to quick sort, but it just differs in one slight way, which changes it a fair bit. So thank you everyone so much for watching, and I will see you in